A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. I welcome you all in our today's online session, Applied Physics lecture number 7. Hope you all are fine and having good health. We start today's session with the words of Holy Quran. In previous session, we was discussed about the concept of electric lines of fields, electric lines of forces, or electric field, the flow of electric field uh, with the shield and charged by the conductor. That conductor field that electric lines of forces and the region create around that particular conductor, it looks like in figure A and figure B. So this was our last lecture on the shielding and charge by induction. So further, we are moving towards the concept of shield and charging by induction. The electric field is stronger where the surface is more sharply curved. You can say the whole shape is sharply curved, all its sides. So the electric field of lines are dispersing outside from that particular surfaces into a different kind of regions. So we can say that the lines of forces are emit from that object and disperse the lines of forces in terms of electric field in this region. Now, the next same aspect, a conductor can be charged by induction if there is a way to ground it. This allows the like charges to leave the conductor if the conductor is in isolated before the rod is removed, only the excess charge remains. Means that if we have a rod of negatively charged, and we provide to the surface like this, so the other like charges which is exist in the substance are negative are far away from that particular object outside another way, and the front side opposite charges are embossed like this one. And if we ground this substance of object in this way, then these charges are further de-vanish, A, B towards C. And afterwards, if we remove that bar of negatively charged object, then the whole surface would remain the positive charges in this body. So that's how we positively charge a particular object by this technique. And only a positive charge exists in that object of body. Further, the electric flux is measure of the electric field perpendicular to a surface. अब इस स्लाइड में अगर हम देखें तो इलेक्ट्रिक फ्लक्स की डेफिनेशन we all know that the electric lines of fields passing through per unit area is called electric flux or its flux, we can say. So the lines of forces, if passing through a particular area, then it become the flux. So the formula would be phi equal to E electric lines of forces multiply by area, particularly by which the lines of forces are going through, and multiply by the cos theta. The cos is inclination angle between the electric lines of forces and the particular surface of phase. That origination of angle is called the theta. So the SI unit of that particular flux is Weber. It's a drive unit, but in terms of nominal units, they are Newton meter square per coulomb. This is how the concept of electric flux originate from electric field or electric lines of forces to electric flux. So that's the way that how we can explain or modify or tell the concept of electric flux by electric field or electric lines of forces. So now Gauss's law states that now this comes to the concept of Gauss's law after electric flux, because electric flux is mainly play a role in Gauss's law. The cumulative all kind of flux, when we add to combine the equivalent flux, then this concept further originate the concept of Gauss's law, the electric flux. So we talk about the electric flux concept with the Gauss's law. So it states that the electric flux through a closed surface is proportional to the charge enclosed by the surface. So जैसे कि हम ये देख रहे हैं कि गॉसेस लॉ के मुताबिक वो इलेक्ट्रिक फ्लक्स जो कि क्लोज सरफेस से प्रोपोर्शनली चार्ज इनक्लोज सरफेस के अंदर होता है, वो टोटल इनक्लोज के बराबर होता है. व्हाट मींस कि अगर एक अनवेट सरफेस हमारे पास मौजूद हो और इसका टोटल फ्लक्स हमें मालूम करना हो, तो हम ये जानते हैं कि एक अनवेट सरफेस का शेप डिफाइन नहीं होता, कांस्टेंट नहीं होता, तो उसका फ्लक्स मालूम करना हमारे लिए नामुमकिन वाली बात है, एक चैलेंज है. तो उसको मालूम करने के लिए हम एक बड़े सरफेस को छोटे छोटे पैचेस में, हिस्सों में डिवाइड करते हैं और उनका इंडिविजुअल फ्लक्स मालूम करते हैं और उन तमाम इंडिविजुअल फ्लक्स को ऐड करके टोटल इक्विवेलेंट फ्लक्स मालूम करते हैं. दैट्स द रीजन यहाँ पे एक टर्म इस्तेमाल हुई है, इनक्लोज्ड बाय द सरफेस, यानी उन तमाम के तमाम सरफेसेस को इनक्लोज करते हैं और उनका एरिया मालूम कर लेते हैं, जिसके जरिए से हम टोटल फ्लक्स को मालूम कर पाते हैं जो कि इनक्लोज हो रहा होता है एक अनवेयर्ड सरफेस से. दिस इज द कॉन्सेप्ट विच टेल्स बाय Gausses to us. So the formula is phi equal to q upon epsilon naught. Same phenomena as we previously discussed about the concept of flux from originated by the electric lines of forces, but formula now that it would be changed as the tells by the Gausses. So this formula we got by Gausses, and the previous one is we originate from the basic scenario in between electric lines of forces and the area enclosed by the area by which the field of lines are flow. That particular concept we discuss as the electric flux, phi Ea cos theta, and here phi equal to q upon epsilon naught. So the previous formula is the basic one, and this one is the drive concept of flux in terms of Gauss's law. So this is the SI unit. E naught equal to 1 upon 4 pi into K. This is the E naught is a term permittivity of free space, and it having the formula and value 8.85 newtons to power minus 12 coulomb square per Newton meter square. Now electric flux and Gauss's law. So this is the positively charged sheet, you can say here, and the lines of field are going through from positive side in this one is direction and another one from this direction. So in the same and opposite direction, both the lines of forces can be flowed because only a positive unit test charge is placed there. So the particular area, if we imagine here, the lines of forces, if flowed by this area, then in this area, the flux would be flowed from in this direction and the opposite direction as well. So this is the concept. So it's the end of this chapter, that, and we need to revise a summary of this chapter. And the concept are electrons having the negative charge and proton at the positive charge with the same magnitude, and it have electron and proton Same charge, but in opposite side the direction, E equal to 1.60 × 10⁻⁻19 coulomb. Unit of charge is coulomb of a particular charge. Charge is conserved. Conserved means constant रहता है या तब्दील नहीं होता, magnitude जो है, and quantized in the units of E. Insulators do not allow electrons to move between atoms. Conductors allow conductor allow conduction electron to flow freely. So in conduction band, electrons are move freely and fulfill the conductivity from one conductor to another conductor, or the same conductor from the valence band to conduction band. This is the concept of band theory of solids in micron level. So another concept that we studied, the force of electrostatic charge in along the lines of conducting them, the like charges repel, opposite charges attract, the fact phenomena. Coulomb's law gives the magnitude of forces, and the formula was F is equal to KQ1 Q2 upon R square. This is the force of attraction repulsion between the charges that Coulomb tells to us. Now, here is the K value 9 × 10⁻⁹ Newton meter square per Coulomb square. Forces exerted by several charges add as vectors. So this is the concept of exerted forces charges and the concept of Coulomb's law. Now, after that, we discussed the spherical charge distribution behaves from outside as through the total charge, where at its center, electric field is the force per charge for a point charge. Mainly the concept of electric field intensity, that is derived from Coulomb's law. The formula would be looks like E equal to KQ upon R square. Electric field created by several charges add as vectors. So the multiple lines of phasors or the lines of forces in terms of arrow, we can see in previous slides that the positive static charge can float the electric lines of forces into a region by which we going to study. So electric field lines help visualize the electric field. Field lines points in the direction of field start on positive charges or infinity, and on charges or infinity are denser where E is greater. Parallel plate capacitor concept we also studied in our previous slide. Two oppositely charged conducting plates parallelly connected with, not physically connected, they are placed in parallel notation with each other, opposite positive and negative symmetry. Excess charge on a conductor is on the surface, which is collecting by the positive. Electric field within a conductor is zero if charges are static. So another concept that we discussed in this lecture, a conductor can be charged by induction. If the induction fulfill, so conductor can be charged. Conductor can be grounded. The rod on sphere experiment we discussed in our previous slide as well. Electric flux through a surface we also discussed here, that phi equal to E into A cos phi in the formula. That is a particular formula. By basics we derive from flux. Weber is a scientist who tells the concept of flux. Another concept of flux that tells to us that the Gausses law tells to us that phi equal to Q upon epsilon naught. Afterwards, epsilon naught equal to 8.85 times to power minus 12 Coulomb square per Newton meter square. This is about the permittivity of free space value that we placed in this formula. Afterwards, this is the end of our today's session. If you have any kind of question, query, or difficulty regarding the session, please feel free to ask. I will answer the question and resolve your queries if you have in your mind. This is all about the lecture number 7 of applied physics.